Okay, welcome. Today we are going to look at. Okay, hang on, the screen is a bit too small, so you can get a little wider. Thank you. There you go. Okay, so um, last time we were looking at trying to get something like, oh, that's the layout again. Like these raw enums, C-like enums. Can that be done or not? So can it be done without making everything a mess? That's more like that. So that's the question, I guess. So let's see here. So stuff. There we go. So here we have something. I just broke the formatter. So inserted this debug output. Okay. There we go. And let me see here. So distinct. All right. And then we can get case enum wherever there are distinct. Okay. So the solution I found to kind of make this a little easier is to treat equals, right, equals const enum. That's what it's called now. Enum. This flat is in like yes. So is it a yeah? So the funny thing is, you're like, okay, we are we want the basic kind of sorry, I get distracted of my own from my like reading, like when I type myself. Okay, so this why is this not a switch? It seems like it should absolutely be a switch, and it's not. So switch. That's weird. Type kind of looked like well, something like it was there at some time and it didn't work or something. I don't know. Switch kind of. What? Oops. Right. Kind of. Oh, and switch. Just switch. There we go. And now we need some cases. So case distinct case const enum. We're gonna call this const enum for now. It's a bad name, but const enum, if we write it like this, const enum, that's a C enum. All right, a C enum. Okay, funny. Right, so then we're gonna do for this. So, all right, so case signed int, case unsigned int, case, this is runtime anyway, so case float. In those cases, or a vector, case vector, So here's distinct. This can be put together, and then we have also case constant. So the problem I had when implementing this damn it, the C enums, C-like enums, was that it really would make a lot of code that somehow then had to be just right. One more implementation of everything, and that was just a very painful thing, because then you basically you'd have to audit every single thing, like every single yeah, everything is single thing you really do in the source code, the standard library, everything, you know. So let's see here. So int from any, so it's a distinct. So we take arg is or. Oops, what did I do? Hit the wrong one. So I've been having problems, by the way, with the with CLion. It's like code completion suddenly would do something completely different. Const enum is really bad because it's hard to figure it out. Oh wait, that was not one, right? So const enum should be const enum there. Right, I think that's it. Let me just check those changes I did. So for the formatter, that's there. Okay, so how did I solve this in a fairly sane way? That was basically by mostly making it similar to a distinct type. So the distinct type already has basically the same behavior that we're expecting from the from a C-like enum, right? It has the conversion, right? And you can have you want to have it real time, or like keep the type, but sometimes you want it inline. So I basically made it possible to do it inline. I'm just going to go to this formatter and here, and actually I want to check it one more time. So there we go, the const enum. We're already on these are the ones. So here we go, const enum. You're not seeing this, I'm sorry. This is on my the kind of pop up here. Yes, let me look through these to make sure that it is. Oh, it's crashing here. And damn, it's like CLion is really not happy these days. I don't know if it's because we. Oh, damn it! Let me kind of turn up. Maybe it's because of the the C3 highlighter, which is not quite working all the time. Okay, right. So anyway, so I patterned it off of distinct. So that kind of let me do not like knowing where I should go in and change things, and also it also already has the same behavior, so we're not really adding anything with new behavior because it's essentially a distinct. So the only difference between a distinct type and this const enum type is that oh, it's really slow now. Whoa, this is amazingly slow. Okay, is that you can do the inference, right? So here we have a const enum, right? In this case, it's actually even inline int here. I'm just writing it like this. Oh, sorry. And this is not final syntax. I don't like this. It's going to get so indented. It should be. I don't want to do this either. So it has to be maybe something else. Anyway, so you can see this one is 4, right? This one is in third. This one is like grabbing the value from before, and this one is getting another value from 4. I was thinking like maybe you could have recursive and do that, and just in case it's like they kind of defined in order, you can still get it. But I don't know. It's just looked a bit complicated. So kind of what we expect to see here. I didn't have the inline, so we don't expect this thing to work, right? But we expect kind of this thing to work. If we get an e here, we could cast a value like 4 to foo, right? And this should all work, right? Oh wait, did this one convert implicitly? Yes, it did, because even though I have inline, that's weird. This should not be converting. So let's see. Okay, so yeah, we're getting that. So, but we can still cast it explicitly, right? And as you see, kind of get the ABC here. This it gives you something back, and this means we can do stuff like that as well. So it's like a typically a C enum, basically. Here it is. But you have this, you have to cast it, so it's a bit safer unless you have the inline. So I think I've actually right now it's kind of working. So let me try something that I haven't tested. Let me just check if you have questions so far. So, okay, are you still having like keyboard tapping is louder than your voice? I'm sorry. I can turn up, but it's because the microphone is from the computer. That's probably the reason, right? Can you still hear me? I can increase the volume more, the mic sensitivity even more, but you will hear my my keyboard. Okay, so let me assume that you want me to do that. Right, so just let me know, so I can actually increase the input volume a bit more. So that should be a bit right. I hope you hear me. Right, it looks like it's the microphone is it should be big, should be loud. Sorry. Right. So let me know if you still can't hear. Sure, more sensitivity. Sorry. So you're hearing me or not, Josh? I see you're there. Oh, okay. Anyway, I hope you hear me, and I'll just move on, and you can complain later in the chat. So, okay, we are at here at the part. What would happen if we have a string, right? So now I have ABC something, right? And we have df. We can have that. Okay, maybe we have x, right? So this will not work. It shouldn't work. Enums with missing values must be integer type. Okay, all right. So we don't have that. So we just going to go for something else. But we should be able to do bar equals maybe this one, right? And then we should be able to print that. Right. Let's see what happens. I haven't tried this yet, so this is the first. Okay, it does. Oh, to take print on. So it does print that one, right? Everything looks good. So you can do something like bar baz. Then we can do like if bar equals baz and do something equals, right? And now that prints, obviously prints something equals, but if we do instead, we can have, the thing is that if you have a string that will, since this one is a string and this is a literal, I think this should work. I'm not sure. So for now, let me just try that out. Okay, we got it casted, but this should work. Okay, so we get a equals, but what happens if we put something else there? Do we see get equals? No, we don't. Okay, as expected, right? Okay. What happens then if we have something that can't be compared? Right, we can, what if we have a struct foobar, which is int a, right? And then we can have const enum baz, which is a foobar. In this case, we want to have our y is 1 and z is 3. Now, the question is, what do you think? Can we compare those? The answer is no. So baz, what's baz z? So can we, do x equals z? Same. Does this work? No, it doesn't. And because they are not comparable, oh, we get a, oh, I get even an error. Whoa, we have a bug here. So okay, resolve state is done. Well, let's just search. Okay. Let's see what that came from then. So we are analyzing this with the inferred type of decal. Right, and then we go to here. To type is an enum of type baz. We analyze the analyzer, we flatten it, and the flatten type is foobar. Okay, and then we start to analyze the expression, and it's running, and we analyze it here. Okay, so why do we assume that it is const? Okay, analyze inferred expression, right? I think this is a bit weird if it's analyzed initializer. So flattened that part, decal. Okay, maybe we didn't quite yet resolve the type. That is a possibility. That's a possibility. We didn't yet resolve the type of the struct. Okay, it is now. It's behaving okay. Yeah, that's true. That's the way. That's what happens. So when we go to raw enum, oh, damn it. Okay, this is so slow now. I have to maybe, I'm not sure what's like really killing this, but it's not fast. There is no need for actually this to be slow other than it is. Okay, so if you go back, and the raw enum, so what we see here is that we have a type somewhere here. So we resolve this type info, and the thing is, once you do that, that type should already, no, it doesn't necessarily resolve the type, so if not type so there's a sima type tickle type tickle resolve type tickle, yes. So we're gonna need that, so we're gonna do that on the type, which ensures that the enum is already resolved. No, let's see if that works. Okay, so Z could not be found. You spelled right, yeah. So it actually should, I think it should resolve. Oh, it's a bad Z. That's odd. Anyway, or did it? Yeah, that's the one, right? So yeah. What? Why did we compare those? Okay, something broken. I wonder what the resulting code is, though. So, because you kind of get the base here is a value. Now we get the same. Whoa. Okay. That was unexpected. Okay. Debug stuff. Let's have a look at the output here. LVM. That's probably it. Or yeah, it is. So we get the X. That comparison though. So it's so it's actually we're getting a comparison that is a plain memory comp here, memcomp. I didn't expect that. Like I expected that from the other, but not that one. Okay, so let's see why we get it. So we can actually look at the comparisons. So this doesn't seem to be the right behavior, even though it's kind of nice. But I don't think it actually works properly. So let's see here. Sima binary comp something. Binary overload, analyze binary. So we're going to go into that. We're going to have some equals here. Analyze comp. This is the one I wanted. So let's go in here. Damn it. We're just going to hit a lot of those. So I just have to turn off the standard library for now. So it's just gonna, let's just do something else. I'm just gonna assign x equals something, some value. We can track that easily. Okay, so it looks like this is possible. It's looks like actually it might not be super horrible to have this. Of course, if we do, then I'll drop all the inline of associated values. That's kind of complicated, to be honest, and I'm not really that happy. Okay, so here we go. So we have a const enum on one side and const enum on the other side, right? And we have a comparison, and we're going to go here down. If it's user defined, then we're going to flatten this, right? And so the left hand side and the right hand side, what type are those? They should be the flattened. So no. Flat. Okay, no, it's true. That's true. It's just do that for the inline. So right, here we go. So we can actually conflate those. Right, like this. This, and we have a type inline. Type inline type. Okay, drop this one. Or drop this one. I think that's the one. Yes, it is. Yeah. Right, and we move this one. And I lost all the markup here, so or the thing here. Okay, so we are anyway. We are here. We see the left-hand type. We don't see anything. It's not comparable at the time. So we're gonna find the max type, which is gonna be like the this distinct, whatever the distinct type is. So you're gonna get bass at the end, of course. And it's not an int, so we're gonna look at, is the type comparable, right? We apparently we are getting true from that one. So so we go here and then we jump to, oh wait, right? So it's gonna be, it's gonna say yes, because way back when I started doing this, it was obviously I didn't think of strings. So so now we're gonna get okay, a type inline here again. So that's gonna be correct. Now it's gonna react it. Type inline is not available. What? Oh wait, type inline is defined further down. Right. So just gonna grab it here. Oh, distinct italic. Oh, done. Okay. So type is this distinct inline. There you go. Right. There we go. Looking at whether there's anything. So does it explicitly convert to true and false ones, 0, values? So operator overloading is fine. Funny rule, so that's just it's just a distinct type. So distinct types of operator overloading. So that's the same for this one. So let's go. Right, BAS does not support comparisons. Right, that makes sense. So, but the problem is another problem was the way they I had to put this. It didn't work with this. Right, so I wanted that was supposed to work. So let's see if we can kind of tackle that issue. right? And I think that's down in the here in the sub expr. Right. So let's go. Oh, okay. It's further up. I know why. We already do it up here. So here we go. Look at this. So what happens is I flatten it, but then I can't do any inference. So this is actually, it's kind of wrong, to be honest, because this was something I was thinking about before as well. If you have a distinct type, you don't really want inference on that type from the underlying type. It's like it's weird. You shouldn't do that. It's a new type, right? But now it should work. Okay, so BAS does not support comparisons. Good, right? So we can call this compact, right? We compact. And now we can compare them, right? So let's add the change so that we have a trust. What's the other? There we go. Oh, they didn't match. Oh, I forgot the print. Okay. Right, now we should see the same, right? Yeah, it works. Hooray. And if I do something like that, and we have the Y instead, we see not same. What? Oh yeah, we just see, okay, we have to do like this, right? So okay, right, good. Okay, so that's kind of doesn't for one. So does it implicitly convert to true and false for 0 and 1 enum values? Not right now. Not right now. I don't know if that's a good idea to do that. Maybe. But since this is kind of behind, you know, I don't know if we should really have this. Right. But you kind of see what it would be like. Okay, Senum. Okay, you want to have Senum like this, Senum. Yeah, but I just don't like that look of that. Actually, it was better the way I did before, was like this. I kind of like the way that was kind of out of the way. But this will change a lot of things. So what I want to do would be like when you enable this, I would basically want to have it like this, so that if I have the associated values now, we have the X, right? And like that. I would like to have it like ABC and then just go back to the way it was. So like that, you know, and not have this, perhaps, you know. So this is like the current, right? So we did like this. But I'm thinking that once you go, like, we can drop this. Or actually, it's like this, right? But we could, visually make it more visually distinct by saying, okay, these are like this, one, and so on. DF3, hello world, and so on. That was the way it looked before, right? So we could also think that maybe we want to do like this. Maybe it's better. But you still see remove all of the equal sign so that the const enums would use that syntax, and then we have our regular one with this kind of syntax. But there's a problem, right? So kind of how do you put all of this in the same standard library, right? If we want to do the other changes, I can have flip a switch, but if I flip a switch, do we need like two different standard libraries then, right? So that is a problem. And it's something someone highlighted before, like what if you need to, compile it differently depending on the version and so on. And you should, like the source code should maybe do different things. Have some switch on top or something. Let me like look at the enums, so we have enum in the standard library. We have the enum map, of course, which is an enum map, and it's not useful for these kind of enums. That's the enum set. Let's see if I actually define an enum. Here we go. Right, so these would be probably would just go into a C enum, but it's kind of a pity, it's kind of a pity. Like when you, I do like do things like this, implement a feature, because in the end you can't really know what you want until you have implemented it. So none of these are actually, a few of them are using any special like inline in the standard library. They are all using, the standard way of doing it. So there is no inline. Right. So after doing this, I feel like I still don't really like this, but this is kind of useful, right? You have a set of them, and you can, infer. You can define stuff and have these maybe somehow compare them. I know they are distinct types anyway. Maybe, it should go away. I don't know. Um, let me know about this. So I could actually check this into dev, right? And the people interested in this branch could try it. So you see, what you could do here is that you could infer it, right? So if I do, like this, we're still having the classic enum here, right? But we're saying, okay, we have a full bar, right? Because maybe like if you do like int, can infer it, right? So if you have equals, right, somewhere, then by definition, and we don't have any associated values, then we can know that this is the C. So they could be compiled together. I can see with me. And then since we are not actually, it's just this case, right? The log priority here has some values, right? And those values are in this manner. So let's go to this one, by the way. There's a log priority here. Log priority. So what we would have to do then, it would not be like this. Or actually, log priority. I mean, damn it, why does it look like this? Oh yeah, it's enum. Yeah, okay, right. So in this case, actually, you would just make those in scene, right? So like this, and then we have this kind of. Why doesn't that work? Nice scene, and it would, it would work straight off the bat, as you expect it to be. Like, actually, in something like this, it's kind of bad habit to add these extra, and this one is also wrong, So there's that too. You shouldn't do that. It's just too much stuff, unnecessary stuff. All right. So okay. Right. So let's see here. So Ghost Listen is a C3 version in the project file. Right. I don't need different enum syntax for different types, and not just enum syntax for different types, and not just a different keyword. Yeah, I mean, you could definitely have a different keyword. I mean, it's just that this kind of syntax was optimized for conflating them and kind of making people comfortable with using associated values instead of C enums, basically that. So you could use them to compare and so on. But it all depends, It just feels like maybe I should, go and right. I could like, what's the migration path, right? So the migration path could still be, we are actually where we actually reuse this, and well, later someone using this later standard library will just be able to use that, and if they have some older code, it would kind of work, but show deprecation. So what I'm thinking about is like, okay, so if it looks like this, right, or just int example, right, then you can infer that as soon as there are equal signs, this is a C enum and should be handled as such. So then you don't need more than one keyword. But I am somewhat, maybe we could have like const, right? So constant. Still, it still can still satisfy things like the interfaces and so on. So oh, I accidentally muted myself. Sorry. So I am not sure. At least now it's implemented more or less, right? So you can play around with that. As you see, you get like the standard thing. You can like for you don't have any type inference, right? If you do like this, you have to have the whole thing because you can't infer things. But whatever you want to do is like it's there, right? So I don't know. I don't know. It's hard. I would like to remove all the inline and stuff like that. Actually, it's I find, despite having written it, I find the inline. It's just so very advanced. Like if I read code where they use this inline, that is a bit, hard to understand. Whereas a plain enum, C enum with a number is easier to understand. Right. This was what I did before. Const enum. Consts. Yeah. I don't know. Migration path is also like making it a bit, making me a little less happy about it, and it's just so bad too, because you can't print it. I don't like that, and you can't really do much stuff with it. These enums. They're stunted, and if you use them, like, I don't know. Like, does this compile now? So let me show you something. Oh. Okay, I apparently removed Baz. Let's do that. Okay. Right. So if we look at just a normal enum like a ABC, we're gonna make one and we have this inline. So we have some value like mask, which is the inline thing, and then we have like up, which is mask this, and down, which is mask right, something like that. Maybe we should have binary instead. And then we have another one, which is the const enum, which is just int then. Again, we have up is this b, and down is right. So let me just put this into test. And now we are going to have a function which is going to be like print direction, and it's going to take a look at ABC, and it's going to do like this. So if A, right? Okay, so here we get to the gnarly part. So in this case, we need to have this, right? Type def ABC mask. So we have an ABC mask. So print direction, we have the ABC mask, right? And if A and ABC up mask, I have print up. If A and ABC down mask, we make that inline, right? So we can just do this. Down. And then we do the same thing, but we have the other one, direction 2. So now we have set the ABC2, and then C2 usage is the same. So we can do like print direction 2 ABC to up or ABC2 down, right? And we have the print direction ABC2 up or up or ABC down. I think those work. I don't remember. Let's just see. Okay, we didn't get that. Constant name was explained there. So const enum. Right. Oh, okay. Now suddenly I forgot the syntax. Speaking of syntax and making weird things here. So if I would be at a like have one, if I would do like an interview, right, a coding interview online, I wonder, I really wonder, would they like is mistakes like this, right? So it's not defined. Okay, so then you have to have this, right, mask and mask. That sucks, right? So this is like the best argument for these enums. Where here, of course, we have to do this extra type def to make it better, to make it so that we actually have use it here, right? Whereas this one is just plain, just works, and the same thing here, it just works, right? So I think that's a good argument. But then if we are talking about masks, you could just do a bit struct. So we have a bit struct ABC3, right? And we'll say that what bit? So the first bit is up, that's bit number 2, right? Oh, wait, it's bit number 1. Right? And down is bit number 0. So we have something like, sorry, that's all wrong. So, right? So this is a bit struct, and we keep it in And now we can print the direction of that one as well. So let's print the direction of this one, ABC3. Now we say ABCA up and down, right? Up and down. And then we say, okay, print direction 3. And then we say, okay, up, down. Should work. Oh, colon. So, like, yes, this is better, but it's not, great. I mean, masks are, this is obviously easier than this one. They are pretty much doing the same thing, actually. But you can define this in a more, structured way. That's not to say that it's worthless, just that there is this solution. And you can also do these operations on them. So it's there. So we have a replacement for this particular, like, even though this was nicer than, even though, this one, ABC2, was nicer than ABC mask. This is actually, I would say this is better. Best solution there. So let's take another example. So instead of this with the inline, we do have values, right? So that we want to compare, and they have multiple ones. So again, we are now forced. BDE is, we're gonna have the BDE value is an int, and then we have BDE, which is an inline BDE value. We just call it val, and we have foo, and that's equals to 3, 2, and then we have bar, which is equals to 100. Right, then we have the other one, so we have the NBDE2, which is an int again, and is a constant, right? So constant, and we have the same definition there. So let's say we want to print it. One check something, which one check if it's the right one. So we have print BDE. So in the case we have we get the incoming value, so we get like this BDE value. Then we have to do a lookup and then print it. So we can do like this. We can print first the value itself, v, and then we can print, the value of that if we look it up. So BDE up, lookup v, and that's just panic if it's wrong. The second one would then be like print BDE2, and now I have BDE2, and then we can just do this. We can't really look it up, show any value. We can just, this is the same thing, and we can, and then like if, right, we have to do like this. So if BDE, if v equals BDE, what's the name of it? Foo. Then we can do foo, right? Or we can also do, so that's okay. We can do that, right? And we have similar here. We just do BDE to foo minus foo, right? So they look exactly the same, right? But one uses the BDE value. So now we can do print BDE, and then we have, BDE foo, and print BDE 2, BDE 2 foo. Right. So what I'm doing here is kind of trying to get the feel for this, right? So we still get, like in both cases, we get this 2, right? But we can't do this part of this lookup, but perhaps we can make that work. Add something similar, but you don't have the type. I mean, the enum type does not, the enum value itself does not exist. So you can maybe look up name or something, but you couldn't really do anything else. And this is not necessarily, limiting. You could do something with these, getting the names and so on, and creating this kind of lookup. But it's just that it's not super useful. What we could do actually to make this inline nicer would be, rather than to have define a, this mask. No, there's no way. There is no way, fortunately. Unless this was like, this automatically became some distinct type, right? But yeah, you have to have this extra, this create this type, and then you kind of go by way of that. It's not as nice, but you can get so much nicer debug printouts and so on. So yeah, I don't know. It's kind of right. So syntax is wonderful. So syntax but the default spec C3 enums by far. So yeah, I would just nuke the inline, yes, but and then just the C enums if you want to have the inline. But there are so few cases, to be honest. I would like people to use the C enums. Like this is the absolutely wrong place to have those. Having the up and down, that's wrong, right? It will just be this kind of case, right? So we have this const enum, we have a few defined, and then we want to do something, but you shouldn't, like, you will lose so much when you do that. So if you look at, the Android thing, it's like you would never use that further because it's so useless once you go into let me just again grab that. So right, we have something like this, right? In this case, like, we have the channels, right? The thing is that as soon as if we would do, a const enum of this one, it's just going to be yeah, not so nice. I mean, you can't, here you can, if you have something like this, you have the queued disk, right? And you have the channels and color space. So the channels are printable now, right? It just happens to be like it's going to say auto, RGB, RGBA, right? Whereas if this is what people would think of adding would do a constant, you don't have those names, right? So you can't print those. And now everything is just bad. It's just that people might use that and then curse things because it's not good. It is. I thought this was good in the beginning when I started to implement this, but as I started looking into this, it's just you don't really want people to like mistakenly. Here's an event mask, right? So here's the classic, use for this, right? We have an event mask, and as we talked about before, it should just be um, a bit struct, really. So long here with a bit struct, now we could just it would just still work great. And here, of course, the any is all like the full thing, which you can get by negating it. And we have some event modifier. As see here, like this is actually the bit, right? So the 16, 17, 18, 19, and so on, these bits that are supposed to be, done. So we have, okay, so we have this like the event type from value. But in this case, okay, so yeah, you get the value and then you go back. But again, this is like from, because we're mapping from the types, so we get the types back, right? Yeah, so I don't know. Like it's so painful not being able to print this, and it's just yeah. It's not so good. Right, okay. All right. So I don't know if you have any questions. I'm kind of done with the feature, but then maybe the feature is done too. I mean, that is not, you know, it shouldn't be. I mean, this feels good. This feels right to me. I think that like if we could make this automatic, kind of make it a special type here automatically, then a lot of things could, be nicer. But like you could, if you say, for example, that the type here of this is instead of something like this integer, instead of it being an integer, is like event type value val or something, and that's like the type of it. Then maybe, I mean, and but it's only in the interface, right? It's only in the C interface also. So that's what I don't like. It's yeah. Let me create a branch so people can look at that. So C enum branch. So C enums calls enums. Okay. Wait, there is also, yeah. I was planning on maybe turning it on, turning it off. Okay, it's not quite 100% done, but it's getting closer to it. Have a look if you want to. I just feel very ambivalent. Uh, I definitely see that there are advantages, but it's also, advantages that comes from, like, in the beginning not using C3 features, right? So we're not using C3 features, and then we're trying to make it, with that missing C feature, and we're trying to build it in that way, and we're not thinking about like whatever other ways there are, and that's why we have problems. And say, okay, C3 enums suck, and they used to, there wasn't, I can understand is people had problems with them before this inline, but now we have all these inline conversion rules that you can play around with, the lookup and so on. There's really no, um, it's really not as painful as it used to be. And so then, so I kind of end up, is it worth it? I think the benefit, the benefit of having it always printable is huge. To be honest, it's a great thing, and it makes everything very easy to reason about. So I don't want people to use those as enums. Maybe like if we rename things, like let's not call it an enum. It's just let's call it like a const set. That's something I talked about before, like a const set or something. So people, when they see it, it's like, okay, it's instead of enum, it's just a const set, right? And then we have these, and people understand that there is something funky going on with that. So const something, const, I don't know. Okay, so if there are any are there any questions? Right. Okay, so it feels like it needs to be a Mobius, which has been used, and the default one should be easier. So right now, inline seems a bit harder to use, right? Yeah, in these kind of situations where you have, where you do, you have some external value that comes in that you need to map your to your enum, and then yes, it is a little worse. In C, you could just use that particular value, right? But there are no guarantees that those values are not overlapping, same name, same numbers being reused, and so on. So I'm thinking that the binary format, the binary actually, if you actually save it as a binary, transmit it over wire, then you want to have it declared actually as like an associated value, which is a serialization value, right? The downside is this deserialization, where you have to look at the number and see like what does it match. In the case that that would be like a big cost, then maybe we could make something work that makes it really cheap. But we're still, I mean, it's unlikely to be the problem. Yeah. I tried to make it more useful, like by having any type, right? So it's actually a const, a set of consts. But I just think this makes it worse. The feature is worse by making this, making it possible to have, things like this. Um, yeah. So, well, um, yeah. It's a conundrum, honestly. Okay, so I'm just gonna read now on the sign. So here, I don't. Book reader says, I only use inline in a single place in my project where I have an odd case of an enum being read as an ordinal, but used everywhere else as an associated integer C value style. That would be broken as C plus C3 plus C enums, but same project I have a regular C style enum with gaps using constants and C, but would make it so much nicer to work with. I think in my case, C3 plus C enums is a good trade-off. So associable way could be emulated with C style enum by doing something like this, blah blah blah, with a macro. So, which is what I'm doing anyway for my C style enum with gaps using constants. So, C enums to me is so good. I mean, maybe referring for C it should be a C enum, right? And how to change this video. So no type of. Okay, so we're favoring having cake and H2 with both in C enum. Basic. So Xenum is like a Xenum with a thousand substitution like some. Okay. So splitting it up with annoying when you do want to link with C, but also able to link with C3. But uses. But it seems that int freeze only work when implementing the method explicitly uses this my type self. I don't know if there are any other comments there, so. So anyway, enums. You can notice that you are not really getting much help here, though, from actually having the enum, right? If you compare this now, we have compared these. Like, let me just, we have, right, an ABC here, right? Let me straight up give you this. Const, we do a type def, just to be nice. Okay, so this is similar to the first one, so we're gonna have like a, we're gonna make a type def, right? And then we're gonna do like const abc mask. We just call it abc3, right? So abc3. We have, okay, sorry, we have one abc4, right? And then we have, abc4 up equals 0b10. Okay, and 1 right down. And in this case, right, we have, if we want to print the direction, again, we do something similar. We gonna have the 4, right? And what really, what I don't think it really beats is this. So we have all those, right? And then we have just straight up EBC4 up or EBC4 down, right? No namespacing, no such thing, right? And now, okay, sorry. Apparently, I left something here somewhere. Const bar, okay. Okay, some casting error. Sorry. ABC. Okay, we have direction 4, right? Right. So everything works with that, and now let's just print this foo, right? So we have a value, and remember this looked like here, right? So we did do this. So let's define BDE3, and we have BDE3 foo, and we do BDE somewhere. So we have type def BDE4 3 equals int, and then we have const BDE3 foo equals 2 const BDE4 3 bar equals 100, right? So again, we can then have similar. So we have BD, yeah, I wrote that one. So and then we pass print BD3 foo, right? And then sorry, actually you can do like this, right? So this is that place you can use inference. Bed, okay, BDE. Right? So we have all those ways of doing it. Like here we have this one actually is a bit more compact and everything. It's like you have to get used to this, I guess, right? Because I was suggesting that you could do like this, create a sub module like this. That would also be a possibility. By the way, I just didn't do that. And now, so now we have like these different possibilities to choose from, right? So we get a little inference here, but not really that much. And that inference doesn't work as soon as we have a mask instead. We know that we can't get print anything, but here the lookup actually costs something. So, but we can still, we don't have to don't have to incur that cost to just compare things, but you can use that for debug purposes. And I mean, the great thing about this one, the const one, is that you can easily expand that one. So unlike the enums, which are constrained, closed, these constants can be expanded on. Yes, sorry, it was not a very energetic kind of stream here. I see that a few more people are here. So what we've been talking about is whether this feature, this const enum feature here that I demonstrated. So here's one with int, and just demonstrate that you could have a string as well. But then we contrasted that use with, like, here are some tests. It's just basically you just get values, so you just get printed. If you do this, you just get these printed as values, not as enums. We did the contrast here with printing stuff and using masks and so on. So there is a bit of a if you have something like want to have the mask case, you would have to have like a type def to make it more palatable, and then use inline. In that case, you still don't get it like super. It will need to look like this. But you can then actually you can make that work. Anyway, so back to here. So you can see this here, which was the direction with the inline. It looks like this, and kind of all of them kind of look the same here. So the mask case, there is no clear winner, except that you can do it in a bit struct, and that one just gets much more integrated. And then we do just pass a value and then check that, and that your value would be some value in of a distinct type. So it would be like a full here or 2, and then you convert that back or compare it, see if it's full, and then we'll see that okay, if we use the enums, the C3 enums, then we have to kind of have our distinct distinct type here that we use. That's a kind of trick. Whereas the C case, we just use it, but we can't print the type. And here's just using constants, we end up with exactly the same as C. So there is no, clear. I mean, anything you can do with the C enums you can do with constant, but the constants are not. You have to define it, with a type def first, and then go to constant. They don't feel like they're together. You can't iterate over them either. So and you can get names, but that's like the same limitation as with the C enums. So I take questions if anyone has them. All right. Okay. I guess that's it. I don't have anything else to really add to this. So I don't know if I'll put it on YouTube or not. And well, anyway, it's kind of getting late here. So thank you for watching. So see you around. Goodbye.